Okay, in a random sample of 989 packets of gummy type candies, it was found that there were 344 packets of gummy worms. It was also found that of those packets of gummy worms, 161 were sour gummy worms. Of the packets that were not gummy worms, 368 were sour. It said let W be the event that a randomly selected packet of candies will be gummy worms. Meanwhile, let S be the event that the candy selected is sour. Find the following probabilities. Okay, let's go ahead. The first one, the probability of being gummy worms. Well, that was given to us directly. Actually, the proportion was given to us. We were told that the proportion of gummy worms was 344 out of the total 989. 989, and that results in 0.34783 as the decimal. All right, so next we are looking at the probability of not being a gummy worm, which is just 1 minus that. Well, if there's 989 packets and 334 or 344 were gummy worms, that means that 645 were not gummy worms. So we could either do 645 over 989, or we could have just done 1 minus 0.34783. In either case, we get the answer for this one being 0.65217. So the probability of not being a gummy worm packet is 0.65217. All right, now they're asking for some conditional probabilities. So the probability of being sour given that you were a packet of gummy worms. Well, we're only looking at the 344 packets of gummy worms, and of those 344 packets of gummy worms, 161 were sour. That makes for a proportion of 161, but not out of the total 989. We already know that these were gummy worms, so there are only 344 of those. So that's 161 out of 344, which is 0.46802. 802. Okay, that's this answer. And then last, let's see what last in this little block here. We have the probability that they were sour given that they were not gummy worms. That's what we're looking for. Well, let's see what else they gave us. They said of the packets that were not gummy worms, so it looks like we're conditioned on the right thing, 368 were sour. So first we need to know how many of these packets were not gummy worms, or yeah, we need to find out how many of these were not gummy worms. We already said that that was 645, which is the 344 that are gummy worms subtracted from the 989 total packets. We get 645 packets that were not gummy worms. So of those 645 non-gummy worm packets, 368 were sour. So that's 368 sour packets out of the 645 non-gummy worm packets. That amounts to a probability of 0.57054. So 0.57054. And then they finally ask us to find the probability of being a gummy worm given that the packet is a packet of sour candies. So that's an inverted probability. They've been giving us probability of sour given it's a gummy worm, or even sour given it's not a gummy worm. Now they want the probability of worm given sour, which is the inverted conditional. So we need to use Bayes' theorem here. Bayes' theorem. And we can use a tree, we can use the formula. We're going to go ahead in this case and just go ahead and use the formula. The formula says that the probability of a worm given that is sour is equal to the probability of worm and sour divided by the probability of sour. Actually, that's just the regular conditional probability formula. For Bayes' theorem, we look at the probability of the W and S, and we define it as conditional probability. But the probability we're going to use, since we're looking for W given S, we're going to use the probability of S given W to form our conditional and multiply that by the probability of W, because that's the definition, or one of the definitions we can use for the probability of W and S. By definition, a joint probability like this, the probability of W and S, is equal to the probability of W times the probability of S given W. In the denominator, we're going to look at the fact that the probability of S we don't know, but what we can find is we can find the probability of S and W and add it to the probability of S and not W. And when you add those two together, because W and not W are complements, you get the total probability of S. And also, we have the probability of W times the probability of S given W on top. But we can write those joint probabilities on the bottom also as conditionals. So let's see, this is the probability of S given W. For instance, that first one is the same one we already found the product for. We already used the formula for that one, because W and S is the same as S and W. We can just go through and we can find this as the probability of W times the probability of S given W. Plus, that second one we can use the exact same logic, and that one is going to be the probability of not W, probability is not a gummy worm, times the probability that it is sour given it's not a gummy worm. So basically, this down here will give me the total probability of being sour, because I have sour and gummy worms and sour and not gummy worms both included. So I can find all these probabilities. They're all right there, actually. Right there. They're all right there. So let me see. The probability of W is 0.34783. So that's 0.34783. The probability of S given W, probability of S given W is 0.46802. So that's 0.46802 divided by, well, this term is exactly the same as the numerator, 0.34783 times 0.46802. And then this last one is the probability of not a gummy worm, which is 0.65217, 0.65217. And then that's multiplied by the probability of being sour given that you're not a gummy worm. So probability of being sour given the packet is not a packet of gummy worms is 0.57054. So that's 0.57054. And then we just pretty much do this calculation. So the numerator is 0.16279. That first term in the denominator is the same. And then we're adding into that 0.37209. And then that denominator, when you add those together, we get 0.53488. And that quotient will give me the probability I'm looking for, the probability of W given S. So the probability of being a gummy worm packet, given that it's a sour packet, is equal to 0.3043. And that's how we use the formula on one of these Bayes theorem problems when the proportions are given and not the percentages or the decimals.